All right. So exponential growth. So you've probably heard the term. Usually you use it as like something's growing out of control or going really fast. And that's true. And I think we're going to use that to our advantage. So let's start making the table of the situation. Now, here's a very basic exponential function. Y equals 2x. When we make our table, we're going to always use -1, 0, and 1. And you'll see how that changed later. But for now, we're going to always base it off -1, 0, and 1 when I ask you to make a table/graph. So when I say put your domain as -1, 0, 1, that means you're going to put in for your x values -1, 0, and 1. Now, just like any other equation, you could take the x's and then plug it into the y's. Or take the x's, plug it in to find the y. So I'm going to do the first one. I'll do it in green over here. So y equals 2 to the -1 power. You have to remember, negative powers, what it did is it would flip it over or bring it to the bottom. So 2 to the -1 power would bring this to the bottom and become 1 over 2. So this is 1 over 2. You could technically also do this in your calculator. You would just get 0.5. 0.5 is the same thing as 1 over 2. Next one, I'll do it in red. Plug in 0. Here's another rule you have to remember. Anything to the 0 power, equals 1. So since it's 2 to the 0 power, that equals 1. So 0, 1. And then the last one, 2 to the 1 power. Anything to the 1 power is just itself. Kind of like how you multiply anything to 1, it's just itself. So 2 to the 1 power is 2. So that means it's 2. Make a quick little XY graph here for us. So if we were to graph it, it would kind of look like this. At -1, it's a half. At 0, it's 1. And at 1, it's 2. Exponential growths have this kind of like ascending roller coaster style where it looks like it's going up and up. It starts off flat and it's going then up and up and up. So that's how an exponential function typically looks. I'm more concerned about your tables because from there you could graph, but the tables are the harder part. So I want to make sure you get that done. But typically the shape looks like it's ascending up like this. Okay. Does anyone have any questions on this first one before we go to the, let's say, the next level?
Mr. Tobal?
Yeah.
What was like the thing you just drew, like explaining it with like?
Oh, so I'll use the colors to help me out. So here is -1, so I went 1 left and a half up. So this would be my first coordinate point, kind of like when we used to graph lines. Here is 0, 1, so I went 0 left and right and 1 up. And here's 1 comma 2. It's 1 comma 2. Now this is the graph I drew. Typically the graph looks like I always said like a ascending roller coaster. So it's like going up the roller coaster before you fall down. But you never fall down. You just keep going up to ever. So that's how the exponential looks like. Or it's like going up a hill or something like that. Or going up a cliff, I guess, because it gets really sharp after a while. That's how an exponential growth function typically looks. Like, that's how it normally looks, I should say. This is how it normally looks. And we'll see where it changes a little bit here and there. But for now, this is the basic look of a exponential function. Exponential growth, I should say. So let's do our next problem. Let's extend it a bit. Our next problem is going to be y equals 3 times 2x. Let's just say 3 times 2 to the x power.
It doesn't show us it, so I'm just waiting for it to like show us it.
It doesn't show it. Let me just go full screen then, or just let me.
I see it.
Yeah, depending if you're on a
Yeah.
phone though, I could see if you're on a phone, it might cut it off. So let's just do it like this.
Now I can see it.
Yeah. All right. Now the steps are going to be the same. No need to recopy the steps. I'm just going to bring it down here just so we have it as reference. Now what we have is a b value, or an a value, which was from the original over here, abx. That doesn't really change anything. It just goes to add a little extra math to us. But otherwise, it doesn't really change our steps or anything like that. I hate when they're crooked. Let me fix it. All right. So we're going to make a table again with x and y. And we're going to have our domains still be the same. -1, 0, and 1. I'm going to do first green. Let me use green again. And we're going to do the same thing where we're going to plug it in. This time, though, we just got to be careful in our x's and y's. So 3 times 2 to the -1 power. Now, the -1 power is only on the 2. So only the 2 becomes a half. So 3 times 1/2. That negative power is only on that number inside the exponent. So only that number inside the exponent moves down in that case. This is a whole number 3, so I made it 3/1. 3/1 times 1/2 gives me 3/2. Again, if you do this in the calculator, you will get a decimal, 1.5. That's the same number. I'll even put it right here, 1.5. Sometimes it's easier to graph with a decimal, so there's nothing wrong with changing it to a decimal if you want to. Okay, the next one, 3 times 2 to the 0 power. Only the number with the exponent becomes 1. So this is 3 times 1, because only the exponent value gets 1. So it's just 3. So you plug here, just 3. Last one, 3 times 2 to the 1 power. This is very straightforward because 2 to the 1 power is 2. So 3 times 2 equals 6. And I'm going to make a really small x and y. The shape is going to be the same. So at -1, it's like 1.5 up. At 0, it's like 3 up. And at 1, it's really high up. It's like 6. So notice how the shape stays generally the same. Even though it's a bigger number and it's a little bit higher, this shape stays generally the same, which is kind of like that upwards hill motion.
Is there total?
Yes.
For the red one, for like 3 times
Yes.
0, like 2 times 2 is going to be 0. So isn't it 3 times 0, which will equal 0?
0 is an exponent in this situation. So what's here is 2 to the 0 power. And anything to the 0 power becomes 1. So it becomes 3 times 1, which is just 3. That's why it's really important to remember. Anything to the 0 power is just 1. Next one, I want you guys to try to do this yourself. This is not your exit ticket, so don't leave if I say you got it right, please. What I want you to do is to give me the y values for this one. 10 times 2 to the x power. 10 times 2 to the x power. So your process is still the same. You have your domain. What you're going to type to me is your range or your y values. So if I was to type to myself the top question one, I would have typed 1.5, comma 3, comma 6. No, that's a period, comma 6. So that's what I would type to me if it was the previous problem. To see if you guys are understanding it, I need you to tell me and show me what you can do. So type that out to me. When you get those answers, I'll say it's right or wrong so I can kind of correct it, all right? This would be the equivalent of me like walking around and checking like, oh, you got it right, you got it wrong. So everyone try this now. And once you got something down, send me an answer.
Will you show us how to do it correctly after Mr. Trollo? Like our notes?
Will I show the answers afterwards? Yeah. And how to do it? Yeah.
Okay.
Alyssa, great job. Ella, great job. Good. Sheva, good, good, good. Mariah, good job. Just 10 over 2, what does that reduce to? Nice. Good. I'm very happy, guys. Good. All right. Carmela, good job. All right. And Ben, good job, man. So the answers here should be 5, 10, and 20. Good job with most of you guys. If you don't know how we got that, just stay near the end of the class and I'll help you out. But you see, you guys are taking in the lesson, so I'm very happy to see that. Now, we're going to go to our last type of problem, and then after that, we'll have our exit ticket. And I don't know if everyone has had this. I don't remember Eliana or Ben seeing this. If you get the exit ticket right, you're free to go right after. So it's kind of a benefit if you're paying attention, and it shows kind of like, oh, I understand what's happening. Sorry I took that away. Does anyone still need it? Actually, I'll just extend the page instead. All right. So it should be 5, 10, and 20. All right, our last type of situation is where we have addition and subtraction going on. So first, I'm going to draw the generic version. Y equals A times BX. We're familiar with this part already. A times BX. We're already familiar with that. That's no biggie. What's new, and I'll put in like a purple to show it's new, is minus H plus K. Now that minus H is in the exponent, so it's like tiny in the exponent. And that plus K is not in the exponent, is on the outside like a normal size number. So I want to make sure it's minus H plus K. H being a little bit inside and K being that big number on the outside. As you write that down, does anyone, you can speak up, remember where this minus H plus K might have happened before? We did a little bit this year, while back, chapter 1-ish probably. Anyone remember where this minus H plus K seemed familiar in any way?
This is like when we would plug it in with the H's and K's and stuff, and we would like solve it. Like
Plugging in
numbers. Like we would find out which was H and which was K, and with like a B, like there's like a whole formula for it.
It's kind of not exactly. I know what you're trying to say, but no. If I said something, the vertex form, does that ring any bells of any sort? Or the parabolas, finding the vertex, minus H plus K? That's fine. So let's just do the problem as is then. So let me copy down the steps here. So let me copy this. All right. So the steps, the first two steps are going to be very similar. The only difference is make a table, plug in the X's and find the Y's for A times B to the X. And then step 3, you're going to have a new step now. Change the value based off H and K. Change the values based off H and K. And we're going to see how that works. So I'm going to make a question right now. And actually, I'm going to use the baseline of this one from before. So that is 10 times, I'll do it in black because this is our actual example, not work. 10 times 2 to the x power. I'm going to put a minus 3 inside the exponent. And I'm going to put a plus 4 here, okay? So this is our new problem. Y equals 10 times 2 to the x minus 3 plus 4. Now, the first two steps are the same as we did. And from the questions or the answers people sent me, we understood the first two steps. We're going to make a table, which is x and y. We're going to plug in -1, 0, 1. And we're going to use the points that we found. Now, we already found these points in the previous problem, so I'm just going to write it down. 5, 10, 20. If you just want to reuse the old table, that's fine. Now, we're going to change the values based off H and K. First, we should identify what H and K is before we change the values, right? So the H, since it's minus H, it's minus whatever the number's here. So H is going to be a positive 3. And if I remember from vertex form, a lot of people have problems with that. Because it's minus H, it must be minus a positive 3. So H is positive 3. K is plus K, so we just follow the number normally, which is just 4. So H is 3 and K is 4. Now, what do I mean by change the values based off H and K? What I mean is we're going to make a new table, X and Y. It's going to have 3 slots like the old table. But what's different is that for my X values, I'm going to add my H. While for my Y values, I'm going to add my K. So that is what's going to change. My X values, I'm going to add my H. And for my Y values, I'm going to add my K. So I could do that. -1 plus 3, and I guess I'll just show it a little bit here. -1 plus 3. That's going to come in here as positive 2. 0 plus 3, obviously 3. And 1 plus 3, simply 4. So my H values gets added to the X's. My K values get added to the Y's. So here I have 5 plus 4. So this will become 9. I have 10 plus 4. So that's going to be 14. And I have 20 plus 4. That would be 24. So your final table, you don't have to include these side pieces here, actually. So let me actually rewrite that. Your final table is going to be here. 2, 3, 4, 9, 14, 24. So the only thing H and K does is that at the end of a normal problem, you would add your H's and K's accordingly. So that's the only thing it changes, okay?
Where are you getting the Y's from?
Where I'm getting the Y's from? You did it already, Mariah. That was from the previous problem over here.
Never mind. It's like takes longer for your work to like load. So like getting there.
I didn't hear that well, Mariah. I'm sorry. Okay. And then somebody else was speaking, or anyone else had a question?
I don't think so.
Someone else? Or maybe that's just. Let's mute you for a second. All right. So let's go to the exit ticket. I want everyone to give me the Y values of the second table. So you're going to type me what these values are, okay? So it's going to be Y equals 8 times 2x minus 3 plus 6. So Y equals 8 times 2 to the power of x minus 3 plus 6. So you're going to have to do the whole problem. You're going to have to find the original table, which only uses A and B. Then you're going to have to convert it to the new table. With the plus H's and the plus K's. So what you're sending me is just the K values, okay? Or I should say the Y plus K values. Remember, your start is always the same in this case. So what you're sending me, what is the 3 numbers that's going to be in this column after you convert it. If you get it right and I say, hey, you got it right, you are free to go. I realize I don't know the numbers, so I'm finding it also. Okay.
Hey, Mr. Terwell.
Yeah, what's up?
How do we know what H and K are?
H and K are the values based off here. So H is always the one in the exponent and K is always the normal one.
I see. Thank you.
No problem.
Wait, so the H is the exponent?
The H is an exponent and is in the exponent. It's a tiny 3 up there.
Wait, you only want us to send you the like final Y?
Yeah, the final Y's. So 3 of them, right? Kind of like before you should have sent 5, 10, 20. This one you'll send me my new 3 sets. So whatever the 3 numbers are. Because if you get the Y's, I know you got the X's, so that's why it's not. That's why I only need the Y's. I'm good since I'm going to be remote for a long time. I'm recording every lesson, so if somebody knows they got to be out, just shoot me like an email. Hey, I know I'm going to be out. Can you send me the recording so I have that prepared for you and can put it on YouTube and I'll post it on Google Classroom for everyone. Both Eliana and Sheva, great job. You're both free to go. Have a wonderful day. Ella, you got it. You're free to go. Have a wonderful day.
Yeah. Have a good day. Thank you.
You too. Nate, how are you handling this? You good? Oh, Nate is good. All right, Nate. Have a
I
wonderful day.
just
Man.
sent it. And you have a good day, Mr. Toad.
You too, Nate. Alyssa, you got the original Y's. What you need to do is now plus the K value of it. So you got to get the new one, the values. Ben, you're free to go. Alyssa, you're free to go. Carmela, it's a little bit out of order, but that's okay. You're free to go. Oh, you meant, I see what you're saying. Yeah, you're good. You're good, Carmela.
Thank you.
No problem.
You told both you help me.
Sure. That's
I got the H